So image segmentation. So what we are trying to do is image segmentation is we are trying to group pixels together based on whether it belongs to the same object. So we are trying to detect object basically, which is a very important part of image analysis, because that's how humans start to detect, where the desk, where the chairs, where is human. So we are able to identify each object in front of our eye automatically. So this is a very basic function for image analysis, and also for us to create computer visions to allow machines to be able to see and detect objects like how we do. Right, before that, so I would like to bring you to this additional notes, which is under segmentation. Okay. So the G's of segmentation or detecting objects actually lies in, okay, maybe what you can do is you can try to think of a way that computer could locate individual objects in the sample image below automatically, all right, without human interference. All right, so so you can take note that the symbol and background can be of any gray level. So the hint is ask yourself why you can see the symbol and how you can separate the individual. Okay, first, can you just ask why you can see the symbol in different images?
The contrast of colors.
Yes,
Background.
exactly. Yeah, it's actually something to do with the background and also the symbol. Yeah. What actually is the things that cause you able to see and not see, like especially the dollar sign, and also the slash. In some image you could see the slash, in some you don't. So what actually allows you to be able to see and you cannot see? Yeah, just now someone mentioned about color. Yes, it is about color. So when do you see and when you don't see the symbol? Why you can't see the dollar sign here? Because?
Same color.
Just the surrounding is bright.
Exactly. Yes. Because the surrounding is white and the dollar sign is also white. So basically there is no difference, right? Therefore you don't see the dollar sign. But here you could see very clearly as compared to this. You still see, but it's not clear as this one. Why? Because hello, everybody, are you with me?
Yes, sir.
Yes, sir.
Yeah, why do you see this more clearly than this? And you don't see the dollar sign because?
The surrounding is
Yes,
different.
the surrounding and also the color of the dollar sign is there is very big difference.
Bright,
yes.
sir.
Yeah, one is very bright, one is very dark. So when there's big difference, then you could see this dollar sign very clearly. But when the dollar sign with white and the background also white, when there's no difference at all, you don't see the presence of the dollar sign. So basically to detect object is to detect differences. Okay, so that is the first criteria. So an object is a group of pixels which with very different compared to the surrounding, right? And we'll look at what are the difference. In this case, the difference is actually the gray level, not really color. Here, we don't see any color here. It's basically black and white and gray. So we see they have very different gray level. The greater the gray level, the more visible, the more clear the symbol is. And there is no different, then you don't see any object. All right, so difference compared to surrounding is one of the key. Okay, next, how do you actually separate individual object? Like, for example, you see this one object, this is another object. but you see this as one object. Why? You see this as different object, but this is same object. Why do you see them as separate object? Why you say all these are the same object? Because
Connected.
yes, exactly. Because all the pixels here, they are connected, whereby the pixels and the pixels here, they are not connected. So connectivity is another important criteria for us to define object. Okay, so with that, we'll go to the segmentation. So to identify object, we need to, because we said it has to be different from the contrast, okay, compared to those which is on the surrounding or the border. So it must be very much different compared to the surrounding. So there must be some border. So there must be some contrast difference. So you need to define what is the measure of contrast. It could be either gray level, or it could also be color. And it could also be texture. So these are the three main features that you could use to define the so-called homogeneity and the contrast. All right. Okay, so that actually is the features. All right. And after that, there's a second criteria which you say it has to be connected. So connectivity is another important criteria. So how do you define connectivity? It could be full connectivity like this, or it could also be 6 connectivity, just for your information. All right, it depends on the application. Some works better than another. All right, some will be just 4 connectivity. So to define object, there are, first, you must have some form of homogeneity measures. Homogeneity means similar. Contrast means difference. All right, so either gray level, color, or texture. Next, you need to have the connectivity defined. What is the direction of connectivity? So far, so good. Okay, next, great. Next, we are going to look at the 3 main categories of segmentation techniques. Okay, the first one is region growing, shrinking. Then we look at clustering method, and we look at boundary detection. Okay. So region growing is actually performed by finding homogeneous region. Homogeneous means similar. Means those regions where the pixels share the common similar like gray level or color or texture, and then we start to group them together. And then what we do is we try to change them by shrinking the size and growing the size until they no longer meet the homogeneity criteria. Okay, I think that is the basic concept, which I think you need to look at real example. Again, you can click on additional notes, and then you look for the segmentation Excel file spreadsheet, where okay. So this is the numerical examples that I have prepared. Okay, if you look at the image, this is the image. What do you see here? What do you see here? It's basically,
IP.
yeah, IP, yeah, it's basically IP, you're right. Right? So if we were to ask the computer to automatically detect where are the I and P, of course the computer wouldn't know I and P, but at least computer, we want them to be able to segment out, okay, the individual characters of I and P. So according to this method called region growing and shrinking, so there is this split and merge method. So what we do is we always try to check starting from the entire image, and then we check whether the image is homogeneity, is similar enough to be grouped as one object. So we start to measure, okay, in this case, we measure their gray level. So this is their gray level, individual gray level, and we measure their, one of the way to measure their contrast is to measure the variance. Okay, so I calculate the variance. So the variance shows is this high variance or low variance? 3,000, almost 4,000. Well, this is actually a very large variance. So meaning what? Are they the same or not the same? All the pixels here, are they similar to each other according to this variance? The answer is hello.
Yes, sir.
Yeah, are they similar according to this variance?
No.
No, you're right. Okay, the variance is too large, meaning that they cannot be grouped together. Because so what we do is, according to this, we split them. So when too many of them, then you'll find that too much of variance. Therefore, we split them. Hopefully that in a smaller group, then there will be similar enough. So again, for each of this region, we calculate the individual variance. So we have 4 variants here. So each showing the variance for each group of pixels, a smaller group of pixels. And again, the variance here is also still very large. Then indicating that you need to split them further. Okay, so now we split into 2 by 2 group. And now you start to see there are some group which has a very small variance. You see these 2 variants, only 4 and 0.92. And if you look at the pixels, they are quite similar. Aren't they? Are they similar?
Yeah. Yes.
Okay.
Quite close.
Yes. So for this group of pixels, we don't have to split anymore. We can basically group them as one object because they are very similar with very small variance. All right. So this will be classified as one object and this one another object. The rest we will separate further. And to this level, now you have only individual pixels. Of course, then you find there's no other pixels to compare with, only one pixel. Therefore, of course, the variance is 0. But that actually is not what we want. So next, we already split to the smallest level of individual pixel. Therefore, we need to merge. That's why we call the name split and merge. So we start to merge, okay, in this level. So we try to check, okay, whether this and this, what is the variance? Okay, are they small enough to be grouped as 1 pixels, and this one to this one, and so on. So after that, we find that, okay, in this level, so we detected these 3 pixels have small variance, therefore could be grouped together. All right, and this one remains 1 pixels, and then for this group, so we find that these 3 could be grouped together with small variance 2.33, and this one separate pixels, and so on. Are you following? Okay.
Yes, sir.
Next, we increase the size of the block. So now we increase this block. Okay, again, try and error. For each of these, we try to combine and see how. And then eventually you find that, okay, all the pixels here could be grouped together as one with small variance 2.18, and all the pixels here can be grouped together as another separate object with small variance of 1.6. And so now in this area, we have divided into 2 objects, or we have segmented them into 2 objects, one with 2.18 and one with 1.6. And last but not least, we merge in a pixel white. Okay, and eventually we have this as one object, here as another object, and this one separate object. So all together we have 4 objects. 1, 2, 3, 4. And now you can see that eventually this algorithm leads to the identification of the I and also the P. Except you can see that we know that this and this are actually the background, but at this level we still treat them as separate objects. Because knowing that they are belonging to background involve higher level knowledge. All right, but at this moment, so we detected 4 objects, the background, the I, and also the P, and also the background in the middle of P. So everybody, are you clear with split and merge?
Yes, sir.
All right. If you ask me, so how's the questions going to look like in the final or test? Don't worry, I'm not going to ask you to do all this calculation because it's just not practical to do that manually. right? I just want to show you how split and merge work, right? So far, any questions?
No, sir.
Okay, so split
No,
and
sir.
merge is one examples of region growing and shrinking. So you have seen how we slowly, split. So we shrink the size, and then after that we start to merge where we grow the size. All right, until eventually everyone fulfill the criteria of homogeneity. The variance is small enough to be grouped as one single object. And of course, the connectivity also is important. So because we always go in the level where all the pixels are connected. If not, then start to divide them. Okay, so next we look at the clustering method. So this clustering method, we try to group them instead of in this spatial domain. So we start to group them in other domain, any other domain than spatial domain. So the examples that I prepare here, actually the example given in the textbook is threshold, histogram thresholding. Okay, so what they do is they try to group according to the threshold, the histogram. So suppose this is the image, and if you look at the histogram, you can see there are 3 peaks. Do you see that? So each of these peaks actually, according to the split and merge, represents an object or more. Why? Because when you talk about object, that tends to have, occupied certain number of pixels, therefore forming the peak, and there should be similar. So when similar means they should have a very narrow spread, and therefore forming a peak like this. So each peak here should represent at least an object or more. So by detecting the peak in this histogram is detecting object. You get the concept?
Yes, sir.
Like for example, okay, so this is how it goes. First, what you need to do is we try to detect the first peak. So in this case, like 47 to 53. So what we do is we segment out all those pixels which belongs to this range, this peak 47 to 53. So you can see that practically we are actually segmenting out the background. And then we ignore all those that has been segmented, left only or the I and also the P. So left only 2 peak. So then we go for the second peak here, which range from 147 and 151. And we segment out all the pixels which belongs to this range. And you see that we practically segment out the P. And last but not least, we go with the last peak, which range from 198 to 203, which we practically segment out the I. So that's how histogram thresholding, which is one example of clustering method works. All right. So of course, this not necessarily the features value could be color, could also be the texture. So what you need is to detect the peak. So from the peak, you can divide into different objects. Okay, last but not least, we go for the boundary detection. So boundary detection, I give this example, seeded region growing. So what you need to do is, okay, let's say this is the object. So the main idea is to detect edge. That's why they call it boundary detection. So you detect the edge here. All right. So suppose this is the image. So we do Sobel edge detection, and you find that the Sobel edge magnitude is very high near the edge. Okay, and then we start to do the threshold. So we detected these are the edge location. Okay, after detect edge location, then we start to group them together. Try to the connectivity. Remember, so all those which are connected. So we do the label. So eventually we detected 1 and 2. So from here, then we start to calculate. We calculate the average R for all the 1 here. For all the objects here, we calculate their average R and C. So you just need to sum all the R of these pixels with level 1. Okay, so then you get your R and average C. So this will give you the center of the object. Okay, 4.54 and 13.57.5. So this is the seat. So from here, you need to do the region growing. That is, you start to check this pixel with the surrounding. Are they the same? If they are the same, then they can be grouped together. And you repeat that operation until you cannot find any new pixels joining the group. All right, because this tends to be the center of object, so you tend to be able to group those that is nearby, and as you go out, so you find that, okay, then the chances for you to be able to group will become lesser, and eventually you will meet the boundaries. So eventually, so we are able to detect the object. So this is the example of boundary detection. You start by detecting edge before you detecting the center, then only you do the region growing. So it's a combination a little bit with the region growing and shrinking. But this one, you start by detecting the edge. That's why it's still under category of boundary detection. So far, so good?
Yes, sir.
Okay, so if you ask me how the question looks like, okay, the question is very simple. In the exam, basically we'll ask you what is the 3 main categories of segmentation techniques. So you just need to tell me what is the 3 main categories: region growing, shrinking, clustering method, and boundary detection.
Boundary detection.
Yes. Any questions so far?
No, sir.
All right. So now this is the one that we are going into, which is very much related to your test. This is part 2. This is more to color segmentations, where we use different color space. Okay. For example, in this skin tumor detection. So what we want is to segment out the skin tumor and normal healthy skin. So what they do is they convert to specific color, where they have some color scientists who have derived some color space, you know, which has good discrimination power. For example, in this case, they find blue is more discriminant than red. Therefore, they derive this so that you can see that the blue here has higher resolution. You see, the blue, the one nearer to blue, you know, even though it's 10-degree difference, but it covers smaller region. Therefore, it's more detailed and fine as compared to here, 10-degree but cover a wider regions. Therefore, less resolution and more resolution for blue, less resolution for red and green. And also they find that we human, we are more sensitive to brightness. So the middle here is actually brightness. So towards the end here, this is the red and green. So you can see that why they use angle B, because those in between here, you can see the smaller space. Okay. And as you go out, the space is bigger, indicating less resolution for color and higher resolution for brightness. So these are all color space which the color scientists they actually design, okay, to incorporate some properties, and then after tested they find useful, then they become some algorithm for specific application. So for color segmentation, basically it's very much you build a color space which is for what you want. Okay, so it very much depends on the application. There's nothing much other than that I want to emphasize on. Okay, next we are going into the core. How much time do we have? Okay, I hope. Okay, morphological filtering. So what we want to do is if you look at the image here, so usually after segmentation, you tend to have all the small objects and the holes in the main object. All right. So what we want to do is we want to simplify the segmented image to something like this. So what you do is you want to smooth the outline, you want to remove all the small objects, and then you want to combine the small holes into one big hole so that eventually you don't detect so many objects. If you send this for computer to do labeling, so then you will label all this as one object. So then you will detect thousands of objects, small objects, which is not your intention. What you want is eventually you have only a couple or just the most 3 or 4 main objects like this. All right. So morphological operation filtering is actually the operations that help us to do that. So they help us to simplify segmented image so that you could search the object of interest easily. So how do you do that? You do that by smoothing out object outlines, fill out small holes, and eliminate small objects. Right? In our discussion, we'll focus on binary image, although this one you could extend it to gray level easily. Okay. So the 2 main principles, morphological operations, are dilation and erosion. All right, so dilation, what we do is to expand the object so that we could fill up small holes and also connect the disjoint objects. And erosion, what we do is we erode their boundaries and remove or eliminate small object. Oh. Okay, so I think we may need to have second session. Or can we stop here and then I open up another Zoom session so that we have more time for it?
Okay, sir.
Okay, I think never mind. I think we will stop here. Since it's already 12, some of you might have other online classroom to join. I think we will have another session maybe this Thursday where we have more time to discuss about morphological filtering.
Okay, sir.
Okay, all right. So thank you for your time. So we'll see you again this Thursday morning, maybe 9 o'clock or 9:30.
Okay, sir.
Yeah,
We wait
before
for your
that
email.
maybe. Yeah, okay. We need to take your attendance.